Inside a Cisco ACI fabric, connectivity is a matter of highly automated internal harmony. Within this environment, endpoints communicate seamlessly through predefined endpoint groups, isolated from the noise of the outside world. This setup allows the network to automatically classify, move, and secure every device. Whether the fabric manages 10 servers or 10,000, the security rules follow the workload across any physical port without requiring manual configuration at the switch level. But even the most efficient fabric eventually hits a hard limit. A data center is an isolated island if it cannot reach the public internet, communicate with legacy hardware, or provide services to external users. In traditional networking, bridging that gap often meant creating a raw transport handoff. You simply punched a hole in the perimeter, frequently resulting in an uncontrolled edge where security policies and granular visibility were difficult to maintain. ACI addresses this by establishing a strict physical classification line. Any endpoint discovered within the fabric's internal groups is inside. Everything else, every network, user, or site beyond that handoff, is defined as outside. The challenge is to bridge that divide. The fabric must extend its reach to the outside world without fracturing the centralized policy control that makes the system work in the first place. To cross the boundary, architects choose bridge at Layer 2 or route at Layer 3. Layer 2 stretches the policy outward, extending an internal bridge domain to an external switch. This preserves adjacency. The external host acts like any ACI endpoint, bypassing routed hops. However, this approach carries a specific trade-off. If the internal bridge domain is not set to perform routing, the external device becomes the default gateway for the segment, shifting the responsibility for first hop behavior outside of ACI. Layer 2 extension offers simplicity and proximity, but it forces the architect to decide where the actual ownership of the network edge begins and ends. The alternative is the Layer 3 approach. A designated border leaf switch acts as a robust routed boundary between the fabric and the external world. For operators, it is a mistake to view this connection, the L3 out, as just a simple matter of enabling OSPF or BGP on a port. L3 out requires a deep architectural stack. Access policies, domains, VLAN pools, and interface selectors must align perfectly, otherwise the interface ignores external data. Once permission is validated, the routing layer activates and learns external routes. Route reflectors then push this knowledge deep into the fabric. While an L3 out creates a much cleaner, definitive boundary than Layer 2, its success depends on the operator managing these multiple layers of policy and routing in the correct order. Even with physical and routed connectivity established, we haven't yet reached the core reason for using ACI at the edge. The real power lies in the fact that ACI does not stop applying its internal logic just because it's talking to the outside world. The fabric simply moves its classification point to the very edge of the border leaf. ACI uses external EPGs as anchors, categorizing chaotic internet networks into manageable policy groups. ACI then applies contracts, final gatekeepers ensuring no connection is a free-for-all. Operators dictate exactly which internal groups provide or consume services. Everything else is dropped. ACI isn't just about internal automation. It's about ensuring that the moment the chaotic outside world touches the fabric border, it is forced to follow the same strict, policy-driven rules as every other device in the data center.